We're running the Tesla Coil with two 9-volt batteries, so it easily lights two small light bulbs or one large light bulb. Alright, good job. So we got all three going. 16 gauge AWG wire, 30 AWG gauge magnetic wire, 500 feet, various wire connectors, TIP31C transistor, 100 volts, UF4007 1 amp diodes, 2 of them, 47K 0.5 watt resistor, PCB universal matrix 3 inches by 2 inches, 4 screw terminals with 4 connectors each, 220-degree vertical heat sink, 2-inch PVC pipe, about 12 inches long, 1 incandescent light bulb, 2 9-volt batteries, and a stand. 1 electricity meter, 1 soldering iron with solder, 1 roll of electrical tape, 1 small standard screwdriver, and pliers with wire cutters. As our first step, it's important that we familiarize ourselves with our wiring diagram. So here on the diagram, we have our positive battery connection, our 47K resistor, our diodes number 1 and number 2, our L1, which is our primary coil, L2, which is our secondary coil, our TIP31C transistor with our base, collector, and emitter connection, and finally our negative battery connection. It's important also to note that every time you see a jump in the line, that just means that there is no connection between this wire and the wire underneath on the diagram. Alright, for our second step, what we'll end up doing is placing our screw terminals onto our PCB universal matrix. It's important to note here that for our wiring diagram we have 10 terminals that will be used. When you use these connectors, you end up with 12, so the last 2 we will not use. It takes a little playing with to get these on correctly, but what you want to end up with is at the bottom all the connectors sticking through, so that you can go ahead and wire or solder in the connections on the bottom of the board. For simplicity's sake, what we'll do first is we'll connect all of our wires on this side, completing this part of the diagram, and then turn the board over and do all the soldering on the back, following our wiring diagram. For our first connection, we will have 2 wires connected to our first terminal number 1. One of those wires will become the positive battery connection. The other wire will run from terminal number 1 to terminal number 6. For our second connection, we will be connecting 2 wires. One will run from terminal number 2 to terminal number 8. The second wire will connect from terminal number 2 to terminal number 3. For our third connection, we will connect the wire from terminal number 3 to its neighboring connection, terminal number 4. For our fourth connection, we will be connecting our wire from terminal number 5 to terminal number 10, and also placing an additional wire in that terminal, which will become our negative battery connection. For our last connection, we will be connecting our wire from terminal number 7 to terminal number 9. Before we begin soldering, it's important to familiarize ourselves with the other side of our wiring diagram, where we have here our 47K resistor. Here we have our diode number 1 and 2 connected from the 4th terminal to the 5th terminal. Finally, we have our transistor, where our base connection is connected to the 8th terminal, our collector is connected into the 9th terminal, and our emitter is connected into the 10th terminal. For our third step, we'll begin by placing our resistor, our 2 diodes, and our transistor. Now I'm going to place them on the board exactly how they are in the diagram for simplicity's sake. So we'll begin with our resistor. And the resistor can go on the board in any direction without worrying about functionality. That is not the case with the diodes. The diodes need to go on in a specific way, or else your Slater exciter will not function. The arrow in the diagram denotes direction of the negative side of the diode. So the negative side is the one with the silver edge, so they have to go in the direction of the arrows on the diagram. On our transistor, we are going to place it on the row, but just two rows farther away, so that we can later fit our heat sink on there without affecting the diodes or the resistor. But now with those placed, we're ready to turn it around and begin soldering. Once you turn the circuit board over, sometimes based on the diagram it can get a little confusing. So things get turned around. We have our resistor here, we have our 2 diodes here, and we have our transistor on this side now. So what I've done is I've marked the direction of all of our connections. Connects to our number 1 terminal. This one here will connect to our 2nd terminal. Our 2 diodes will connect to our 4th and 5th terminals. So one side of the diode will connect to the 4th one there, and the far side after the 2nd diode will connect to our 5th. So it's going to kind of go that way, and then these 2 here you're going to connect together so that the current runs in the appropriate direction. And then that just leaves us our transistor, which this now has become the base. So the base will connect to terminal number 8, the collector will connect to terminal number 9, and our emitter will connect to terminal number 10. For our primary and secondary coil, we will be soldering in around 4 inches of wire, which will later connect to our primary and secondary coils. So the first 4-inch wire you want to connect to the third terminal. The second wire you want to connect to the 6th terminal, and the third wire you want to connect to the 7th terminal. Alright, now we're finished with our L1 and L2 connectors. It's time to turn our circuit board over and simply attach the heatsink. The issue with the heatsink is that the connectors don't necessarily fit within the small holes on our matrix. So I had to burrow those out just a little bit and to go ahead and get that to fit correctly. Okay, and then you simply connect that with a screw where the transistor connects directly to the heatsink. The purpose of the heatsink is to prevent overheating and short-circuiting of the transistor with higher and higher voltage. So that's it. You should be done with your circuit board. You have all your connections. L2 or secondary coil. For this step, there isn't a shortcut. It's a matter of taking your PVC pipe and winding magnetic wire starting from one end and winding it all the way up to the other end. Now it's very important that at no place in the coil that 2 wires overlap. By far the easiest step in the Slayer exciter build, and that is the wrapping of the primary coil. The primary coil, you'll use your 16 gauge wire that you've used for everything else, but you want about 4 feet of it. Now you take that and you want to leave a small amount, probably about 3-4 inches on one end, and then that'll connect to your circuit board. Alright, for our final assembly, we have our secondary coil placed onto its base. We have our primary coil that will run down and usually functions right around there, but you may have to adjust it up or down in order to get the best connection. These now on our primary connect to our circuit board. On the diagram it says that the bottom of L2 will connect to the circuit board. The interesting thing is a lot of times it'll function even if it's not connected, but it is also important that you ground the line coming from the circuit board to L2. If it's not grounded, the Slayer exciter won't work. And with that, the moment of truth, let's connect our battery. And it's working correctly, so we'll place that there. And we'll see if we can get three bulbs going. Okay, not too bad. They're a little dim. I think that my batteries are running out of juice, but there you go. The final assembly for the Slayer exciter. I hope everybody has fun attempting to build their own.